Hey guys, Hudson here again. I thought I would talk a little bit about how we classify numbers and how we can remember a funny little imaginative story that can help us remember them. So we've probably all seen this Venn diagram. We've got the real number system. It breaks up. First, we make a divide, and we say we've got real numbers, and inside of real numbers, we split, and we either have irrational or rational. Rational, of course, the root word there is ratio, meaning that the number can be written as a ratio. If you know how Venn diagrams work, you'll see that all of my integers are inside of my rational numbers because any integer value, when I put it over 1, can be written as a ratio. Likewise, whole numbers are included in the integers because if it's a whole number, then it's also an integer. And natural numbers, missaid that for a second. Not all whole numbers all whole numbers are integers, but not all integers are whole numbers. So make sure you realize that -3, for example, is an integer, but it's not a whole number. And I like to remind my students, can we order that many whole pizzas? I can order 0 whole pizzas. I'm doing that right now. I can order 1 or 2 or 3 whole pizzas, but I cannot order 3.7 pizzas. I cannot order -4 pizzas. That doesn't really make sense. And then natural numbers are what we call our counting numbers. It's all of the positive numbers, but we can't include 0 because 0 is neither positive or negative. So essentially natural is just a way to be a little bit more specific with whole numbers and say that 0 is not a natural number, although it is a whole number. So here's a little story that I use to help us remember and keep this straight. When you enter the real number reality, there's a gate. There's a big gate, and there's got security guards. And there they ask you if you're real, and if you're real, they're going to let you in. But in the real number reality, there are 2 places you might be told to live. You might be told to live in the rational road. On the rational road, that's going to include all rational values. So remember, rational values encompass those integers. They encompass the whole numbers. They encompass those natural numbers. So all those values are going to be on rational road. But what we don't have on rational road is the irrational numbers. The irrational numbers are kind of crazy. They get sent to irrational island. Once a number's on irrational island, he's stuck. He's not coming back. So irrational numbers are examples of numbers that can't be written in ratios. Pi is an irrational number. Non-perfect squares, such as radical 3, that's a non-perfect square. It cannot be written in a ratio because it does not have a terminating decimal. So we've got either your numbers are going to rational road or they're going to irrational island. That's the first split that we make. If a number gets to irrational island, it's done. There's nowhere else to go. You party on the island and you have a good time. Next, on the rational road, we see that there's houses, but around some of these houses, there's fences. And the fence is labeled integer lawn. And you see a number partying on the lawn. Let's say you see 7, and 7's on the lawn. And let's say you're the number 14. So if you're the number 14, you're walking down rational road. You made it in as a rational number because 14 can be written as 14 over 1. We know it's rational. It can be written as a fraction. So 14 asks 7, says, hey, am I allowed on integer lawn? And 7 asks 14, are you an integer? Now the way that I have my students remember integer is int, the beginning of the number, sounds exactly like the int at the beginning of entire value. So the 7 asks 14, are you an entire number? And 14 says, well, I don't have any decimal places. I don't have any fractions attached to me. I'm fairly certain I'm an entire number because 14 is, in fact, an entire number. It is an integer, so 14 is allowed to go on to the integer line. Now, if 7 and 14 get too close, they might turn into 714, but that's still an integer, so that's okay. Now, 14 is hanging out on the lawn, and he's enjoying his time, but he decides he wants to know what's in the house. So he goes and he asks at the door of the house and says, how am I allowed in the house? And the number standing at the door says, well, only whole numbers are allowed in the house. So 14 says, well, I'm a whole number. I don't have any partials. I don't have any fractions. I don't have any decimals. I should be allowed in this house. So 14's allowed into the house. He walks into the house. The next door he sees is this door right here. It's the prime playroom. In the prime playroom are all the numbers that are only divisible by themselves and 1. So 7 was out on the lawn. He actually came inside with 14, and he is now inside the prime playroom hanging out with all the other prime numbers, because 7, if I think about the multiples that make 7, it's only 7 and 1. There are no other integer values that can multiply up into 7. But 14 is asking, can I go into the prime playroom? And they look at 14's factors and they see, oh, 14, dude, you can be divided. You can be made by multiplying 2 and 7 together. You're not a prime number. You're not allowed in the prime playroom. You can stay in the whole number house, but you cannot go in the prime playroom. So that's how I kind of remember these things. We can go back and do this with another value. So let's go back and pick a different number to see where their journey will end them. So we start. Let's choose one of our values that we don't have up here. Let's go negative 13. It's a good number. Negative 13. So negative 13 gets into the real number reality, gets to the gate, and they say, well, negative 13, are you real? Do you exist? Are you an actual number? And negative 13, kind of questioning because he's a little bit negative, says, well, I believe I exist. I have kind of a poor outlook on life. I am quite negative after all. Bad joke there. But he is a real number. So negative 13 proceeds on through the gate, and he asks himself, do I go to Rational Road or do I go to Irrational Island? Now remember, Irrational Island is only reserved for those who cannot be made into fractions. Negative 13 thinks to himself, well, I can be made into a fraction if I put myself over 1. That works out just fine, so I belong on the Rational Road. So negative 13 is taking a stroll down Rational Road. He's walking, seeing the sights, and he gets to integer lawn. When he gets to integer lawn, 7 is still on the lawn, and actually 14 is back out on the lawn too. So negative 13 says, hey guys, am I allowed to come on integer lawn? They say, well, negative 13, are you an entire number? He says, well, I don't have any partials. I don't have any decimals. Negative 13 is, in fact, an entire number, so he comes onto the lawn and starts hanging out with everybody else. Then he decides, well, what's inside that house? Let's go check it out. He walks up on the porch, goes to ask somebody if he's allowed in the house. They say, negative 13, hold on just a minute. You're really negative. We don't like negative values here. We do not allow negatives in our whole number house. Negative 13 is a little upset, but he's kind of always upset, so that's okay. He says, you know what, that's okay. I'm going to go and just hang out on the integer lawn. I am an entire value. I'm going to hang out with my other entire values, but you whole numbers, you can stay inside and keep being whole, and maybe they're going to order some whole pizzas for themselves. And that is how I remember my number classifications, is that little trick right there.